Hey guys, and welcome back to another video on the channel. In today's video, we're going to be taking a look at question 13 from the QCAA Math Methods External Exam for, I believe it's paper 2, 2024. Okay. Now, you would have noticed with all the videos on the channel recently, I've been splitting them up into individual videos. That way, if you only struggle with a certain type of video, a certain type of question, sorry, you can go watch it in its own individualized video. And it also allows me to go into a bit more depth on each question. In saying that though, the full external exam video is still up on YouTube. The link will be in the description of this video here. If you guys need a methods external exam bundle pack, the link is in the description below. And there's also now a bundle pack where you can get all 4 exams for physics, chemistry, methods, and specialists if you're interested. In saying that though, let's get straight into this question here. If you have any questions, leave something in the comments or just send me through an email, okay? Okay, question 13. The number of termites in a particular nest can be modeled by n of t equals a over 2 plus e to the power of negative t, where a is a constant, t represents the time in months since the nest first became a visible mold above the ground level. Okay. It is estimated that the I'm gonna get bullied in the comments for this. Mound. I'm going to say it's mound. It's not mold. Mound. Okay. It is estimated that when the mound first became visible, the population was this many. Oh yeah, it would be mound because it's termites. I was like, why would it be mold? Anyway, I'm going to keep that in the video. I don't care. So here, the months since the mound first became visible above ground, it is estimated that the mound first became visible, the population was this. Determine the value of A. So we've got to be very careful with a lot of things in this question here because it is given in months. So if they give you anything in years, you've got to convert that to months with the time, okay? So here when they said when it first became visible, we can assume that's when t equals 0 because the t is the number of months after it became visible above ground. So when t equals 0, the number of termites has to be this amount here. So we can chuck this information into this equation here and we'll be able to work what A is pretty much. So here if we chuck it in, this is what we'll get. So we'll get 3 times 10 to the 5 equals A over 2 plus E negative 0. And then we can start working that out. So E to the 0 would be 1. So in this case here, we've technically got a plus 3 on the bottom there. So 3 times 10 to the 5 equals A over 3. Multiply both sides by 3. So A is going to be 9 times 10 to the 5. So here we can just put the answer. A equals 9 times 10 to the 5. Which means our actual equation for n of t, number of termites at a given time, would be this guy here. And we can use that to probably help us with the other questions. Okay. I'd say that's a pretty easy first question. If you're unsure about where the t equals 0 came from, it's because of this wording here, when it first became visible. If the t is the months after it became visible, when it first becomes visible, we can assume that's when t equals 0. So that's where I've gotten that from. Okay. Alright. B. Determine the number of termites in the nest half a year after the mound became visible. So here, they've said half a year. Now, if time is given in months, we have to assume that's when t equals 6 because there are 6 months in a full year. Now, when it's asking the number of termites in the nest half a year after the mound became visible, all we got to do is just chuck t equals 6 into this equation that we've just worked out here, assuming we've gotten the correct A value. Now, if you didn't get the correct A value at all, you'll get follow through working with this stuff here, provided you do the rest of it correctly here. So here we're going to go n of 6. So wherever you see quote unquote this, you're going to replace that with 6. So we've got 9 times 10 to the 5 over 2 plus e negative 6. And we would chuck that into our calculator. Okay. So if we chuck that into our calculator, we're going to get a number like this. 449,442.97. If we want, we could probably round it up, etc. I'm going to write in scientific notation. So 1, 2, 3, 4, 5. So 4.49 times 10 to the 5 termites, roughly. Okay. Now, if you're wondering where I got that number from, I just chucked that into my calculator. I did not think of that in my head. Remember, this is a calculator exam as well, so we're going to need to use it. C. Determine the time in months after the mound became visible for the initial population to increase by 130,000 termites. Okay, determine the time as a decimal. So here, we need to work out how many termites were there initially, because we need to work out the time in which it's increased by that amount. So that means we need the initial amount plus this new amount here. So here we'll chuck in t equals 0 into our equation here. So if we do that, if I can, so 0, 9 times 10 to the 5, 2 plus E0 gives us 9 times 10 to the 5 over 3, because you have 2 plus 1 on the bottom. Chuck that into your calculator, 10 to the 5 divided by 3. So here we'll just write as, I think that's 300,000. 1, 2, 3, 4. Yep, 300,000. Just want to make sure I get all my zeros right. Yep, cool. Alright, so when they basically said, determine the time in months after the mound, I keep going to say mold, the mound became visible for the initial population to increase by this. So here we need to add this amount to the initial amount, because they want to know the time at which it increases. So what that means is if we add that amount there, we're going to have 4, 3, 0, and then 1, 2, 3. So we're looking the time it reaches that amount, because that would be those two added together. So what that means is we have to set this amount equal to our equation. So because our equation is this, 9 times 10 to the 5, 2 plus e negative t, we want to know the time in which the amount equals this. So we're going to set that equal to there. So we'll have 4, 3, 0, 0, 0, 0 equals 9 times 10 to the 5 over 2 plus e negative t. Now what I would do in this question here is use a solve n on this to solve it by hand. Now because I've made this into individual video, I'll show you how to do it by hand as well. However, you'll have to do the final calculation using your calculator, because you're not going to be able to work this out in any other way unless you are very good at decimals to a lot of decimal places. So here I would try and get the t by itself, so I'd move that entire term up there, and I would move this term down here. So basically we're swapping them. So 2 plus e negative t equals 9 times 10 to the 5 over 4, 3, 0, 0, 0, 0. I would move the 2 to the other side, so you have e negative t equals whatever that number is there, minus 2. Then I would natural log both sides to get the t by itself. So I've got, oh, what's going on with the pen? Negative t equals ln of that thing right there. Again, the solve n would be a lot quicker, but I control the video, so I can do what I want. You guys are just, you probably skip through the comments to the end bit. And then here we just divide by negative 1. So it'd be the exact same thing as that there. And then you have to chuck that into your calculator. But instead of doing all that, because it's a calculator exam, I would just chuck this thing into a solve n pretty much, okay? Now every graphics calculator should have a solve n. If you don't know how to use your solve n, I would make sure you definitely know how to do it, because if you got all that working incorrect, this would be the only thing that's saving you from getting this mark here pretty much. So remember, it's all about like getting as many marks as possible in the shortest amount of time as well, because you only get 90 minutes for it, okay? Now here we get t is approximately 2.37. So remember, now t is in months. So what that means is the time is approximately, quote unquote, 2 1/3 months in. So you can count that to how many weeks if they wanted to, but here they said express the time as a decimal, so that's fine here, okay? Alright. So let's take a look at now D. If you had any questions about that, now we may need the next answers for the other ones, but we'll see what we need here, okay? D. Develop a formula for the rate of change of the number of termites at any time after the mound became clearly visible. Express your formula as a fraction. Okay, so all they're asking for in this question here is to determine the derivative, aka this guy here. Okay, so what I'm going to do is I'm going to rub out this working here because we no longer need it most likely. And we're just going to move this thing. Actually, I'll just write it down here. Like that. Okay, so when we're going to differentiate this, we should probably know really what rule we're going to be using. Now, we are going to be using a chain rule, however, I wouldn't use it just yet. I'm going to move this entire thing up there by making it a negative power. So I still have 9 times 10 to the 5, but I'm going to multiply by this thing here to the power of negative 1. Okay, now we can see we're going to be using chain rule here because you have an outside function and then you have a quote-unquote inside function. Okay, so here the derivative, differentiate the outside, so bring the negative 1 down the front, so you have negative 1 times by this number here, this, then that's going to be to the power of negative 2 because you're going to subtract the power. Then you're going to multiply by the derivative of this. Now the derivative of this is just the derivative of e to the negative t. So the negative 1 comes down the front, so you'll have negative e, negative t, because that in itself is a chain rule. Okay, now let's organize this as its fraction. So we have dn dt. Now here we have a negative times by a negative, which gives you a positive. So on the top of the fraction, we are going to write it as just positive 9 times 10 to the 5 e negative t over, now I'm going to move this down to the bottom because they said express it as a fraction. So it'll be 2 plus e negative t all squared. And that is your first derivative. That's how you answer D. Now here I'm assuming E is going to be using this in some way or another. So E, determine the rate of change in the number of termites 5 months after the mound became visible. So here all they're asking is what is the derivative when t equals 5. So here we're just going to chuck in t equals 5. So dn dt when t equals 5. Wherever you see that t, you just chuck in 5. So we have e negative 5 over 2 plus e negative 5 all squared. And then we chuck that roughly into our calculator because we're not going to be able to work that out by hand in this question here. Alright, let's see what this one gives us. Okay, so roughly this amount here. So this is the increase in termites every, so this is in terms of termites per month because it's a rate of change here. So when it's at 5 months, the rate of change is 1,500 termites per month roughly at that moment there. Now who knows, it might increase or decrease. It's probably going to change a lot because it's an exponential model. But yeah, that's how you do question 13 for this methods exam. Okay. Now, if you have any questions at all in this one here, leave something in the comments. If you guys need a methods external exam bundle pack, leave something in the comment. Oh, no, don't leave something in the comments. Just go to the description of the video and you can see the download there. If you guys need the full playlist, the link is in the description below as well. But otherwise, I'll see you guys in the next video.